Welcome to the second video. I hope that this one looks and sounds a little bit better. All right, we're still in 1.3, second objective. We're going to be solving quadratic equations again, except these are ones where we cannot use the square root property because b will exist. So remember, a quadratic equation, and I should have put in the first video, it's when it equals 0 because this is a quadratic expression. The equal sign makes it an equation. Okay. So the lead coefficient, that's this guy, it's leading the way. We're going to be solving them when the lead coefficient's 1. So essentially, we will not see the a there. It'll just be 1. And then b will exist in this case, so we can't just take a square root because we'll have another x in there. So the main ways that you guys probably already know how to solve these is 1 by factoring, which is how Alex shows you how to do them. That only works when they're factorable. But the way that always works with a quadratic equation in order to solve is my personal favorite, the quadratic formula. And if you do not have this memorized, get it written down. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, when a is 1, it just makes the denominator 2. All right, we're going to solve two quadratic equations where the lead coefficient's 1, and I'm going to solve them using both methods to show you how they both work. I personally like the quadratic formula more because it's very rare to find something that will be factorable, and if that's the only way you know, it won't always work. This way will always work. All right, here is a quadratic equation that we need to solve. It's already set to 0. We can clearly see that a is 1, right, the leading coefficient, b is 2, and c is negative 24. Now, this is a factorable quadratic. I wrote it so that it would be. I'm going to be factoring in white, and I'll be doing the quadratic formula in pink. So first off, the easiest way to factor when your lead coefficient is 1 is find two numbers that multiply to negative 24 that add up to 2. So those two numbers that multiply to negative 24 that add up to 2, and I'll put that dot for multiply, are going to be 6 and negative 4. Now, some of you might have learned the box method. I definitely teach it that way, but you do not need to use that method when a is 1. So I'm going to start just with that method if you're familiar with it, just to refresh, and then just show you how you can do it a little more easily when a is 1. You create a box, and you put the first term first, and you put the last term last. First term, last term. We figured out these two magical numbers that will add to 2 that multiply to this guy over here, 6 and negative 4. That is the way to break up 2x, 6x and negative 4x. It does not matter the order that you put them in these two boxes. We'll end up with the final answer the same. All right, then what we do is we look vertically first. We take out the greatest common factor between this column here. They have an x in common, and that's it. And I write that up top. Then we look here. They have a 6 in common. And you always take the sign of the first box, so it's positive. So we're going to be writing a positive 6 there. Okay, then we look across the rows horizontally. Here, their greatest common factor is x, once again. And in the bottom row, it is a minus 4. Since the first box that we're looking at is negative. So then that gives us our answer. This is one factor, and then this is the other factor. So we are going to write it as x plus 6, x minus 4 equals 0. Now, does that look familiar? Yeah, 6 and negative 4 were the two numbers that we originally chose. And that's why the box method is not super necessary when a is 1. However, we will be seeing ones where a is greater than 1, and then the box method's pretty nice. We're not done though, we have to solve. All we've done is factored. So in order to solve, we use what's called the zero product property, ZPP. This times this is 0. You guys know that if you multiply two things and get 0, the first one had to be 0, or the second one had to be 0, or both. So we're going to set each one of those things, aka factors, minus. So we're going to set each one to 0, and solve. So this is -6 when we subtract 6, and this is +4. Those are our two solutions. All right, in order to use the quadratic formula for this, we are going to plug into the quadratic formula, which I wrote on the other page. So we'll have the opposite of b. I'm going to write out a, b, and c real quick. So we have the opposite of b, -2, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. When we do this, we'll get -2 plus or minus, and then on the inside here, I'm going to have a 4, and then I count my negatives. I got 1 here and 1 here, so there's going to be a plus sign. And 4 times 24 is 96, all over 2. So we end up with, I'll move down here, -2 plus or minus the square root of 100, all over 2. The square root of 100 is 10. And then it's a plus or minus, so we'll have two solutions. Our first solution will use the plus sign, so -2 plus 10, which is 8, over 2, which is 4. Our other one will use the minus sign, so -2 minus 10, which is -12, over 2, which is -6. So our two solutions, either by factoring, are -6 and 4, or using the quadratic formula, we get the same thing. For this problem, I'm going to let you try it on your own, and then you can click back and look through the work through both factoring and using the quadratic formula. All right, we can see that our solution is 4. This solution actually occurs twice, but we only need to say it once. We actually say that the solution's 4 and it has a multiplicity of 2 because it does occur twice. This happens when what's under the square root turns out to be 0. That's called the discriminant. It actually means that we know quadratic equations form parabolas. And 1, 2, 3, 4, since our solution is 4, it actually means that this parabola sits here and looks just like that. So if you were to actually use your graphing calculator and put this in, using an X rather than a W, it doesn't matter. It actually looks just like this, and it sits on the X-axis. So this solution here only occurs it occurs twice, but there's technically just one solution.